Continuing with question number 4. A well of diameter 3 meters is dug 14 meter deep. We know the diameter, we'll get the radius. We know the depth, we'll get the height, right? And they're saying the earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meters to form an embankment. Okay, so remember, the earth taken out from this well has been put to form this embankment here. All right, they've given us a width and everything else. What is our question asking us to find the height of the embankment. All right, so let's go through the given first. Diameter of the well given, so we'll get the radius of the well. Height or depth given, and if we go to the embankment, they've given us a width, right? But now let us try to find the radius of the embankment. All right, so how do you find the radius of the embankment? So it will be from here till here, right? Which means I have to add the radius of the well also. That is why radius of the embankment, how do you get radius of the well plus width of the embankment? Radius of the well is 1.5, where I've written, and then the width of the embankment given to us how much? 4, right? So when we add these two, we're going to get the radius. That means from here till here, how much? 5.5. Question is asking us to find the height of the embankment, which we're taking it to be capital H. All right, so can I say the volume of the well should be equal to volume of the embankment? We can say, right, because once again remember, whatever earth was taken out of here, out of this well here, has been made into this embankment, right? Which means volume remains the same, right? So this is how we'll find the height of the embankment. All right, so the first part is pretty simple. Volume of the well is a cylinder, right? So pi r square h. But how do you find the volume of the embankment, right? So have a look at the top view again. So it will be the bigger, so you can see, right, the volume of the bigger cylinder minus the volume of the smaller cylinder here. Will I get the volume of this embankment? We will get. Also remember, height will be from here only till here, okay? So it will be capital H. So you can see here, that is what I'm doing, right? To find the volume of the embankment, the bigger minus the smaller, I'll get this region here, right? So let's start putting the value. So we can see that from here pi is common, so we can divide, right? Then radius of the well is 1.5, so I've written height 14. The bigger radius is how much? 5.5. The smaller radius will, 1.5. And you can see that what this is in a formula, a square minus b square, right? So if I do the formula for a square minus b square, we get a plus b the whole a minus b. Okay, so there's just what I'm writing it here, and we're trying to find the h, right? So 1.5 square means 1.5 into 1.5. Then when you add these two, 5.5 plus 1.5 will get 7. When you subtract these two, we're going to get 4. So now I'm trying to find this h. So this 7 and 4 will do cross multiplication. It will go down, right? Then 7 on the 7, 7 to the 14, 2 ones are 2 twos are. And then when you multiply 1.5 into 1.5, we're going to get to 2.125. Now divide these two, we're going to get the height of the embankment to be equal to 1.125 meter. All right, the capital H. That means from here till here, how much? 1.125. Right, next question. A container shaped like a right circular cylinder having diameter, you can notice here, given us a diameter, height also given to us, right? And they're saying it's filled with, the whole thing is filled with what? Ice cream, all right? Next, the ice cream is to be filled into cones, all right? That means we're going to take out the ice cream from here and put it here inside the cone, all right? Given us a height, they've given us a diameter, having a hemispherical shape at the top, obviously, right? This is the hemispherical top. So we have to find a number of such cones which can be filled with the ice cream, all right? So let's have a look at the given first. Diameter of the cylinder given, we'll get the radius, height also given, right? And then remember the diameter of the cone, okay, should be equal to diameter of the hemisphere, right? From here till here, so they have the same diameter, right? So we'll get given to us how much? 6, which means we'll get a radius, right? It will be 3, and height of the cone already given to us. So we'll find one after the other, okay? First we'll try to find a volume of one cylinder, and then we'll also try to find a volume of one ice cream cone. That means how do you find the volume of one ice cream cone? It will be volume of the cone plus the volume of this hemisphere, right? Once we know these two, we'll just have to divide in order to get the number of cones, okay, to be that can be filled. So let's first find the volume of the cylinder. So pi r square h already given to us. How much radius is 6, right? So I'm writing down 6, and then height is 15. So multiply this 6 into 6 into 50, we're going to get 540 pi. Just leave it as it is, okay? We'll be able to divide it later on. All right, now let's also find the volume of one ice cream cone. So like I said, volume of the cone plus volume of one hemisphere, right? So we're going to get 1 by 3 pi r square h, the formula, and then the volume of the hemisphere, the formula is 2 by 3 pi r cube. Okay, now let's start putting the value. So the radius of the cone is how much? 3, and of course even the radius of the hemisphere is also 3, right? So we're putting it on, because cube, right? 3 times square, so 2 times, and I can divide 3 ones are 3 ones are 3 ones are 3 ones are 3. Okay, now we'll be having here what 12 3s are 36 pi, right? And when I multiply 3 3s are 9, 9 2s are 18 pi, and when I add this I'm going to get 54 pi. Now let's find the number of cones that can be filled. So like I said, once I know the volume of the cylinder plus I know the volume of one ice cream cone, we just have to divide. So volume of the cylinder we got 540, volume of one ice cream cone we just got it now 54 pi. So I can divide this pi then 54 into 10, which means from the cylinder how many cones can be made? 10 ice cream cones, right? Let's do one more. How many silver coins? So this is a coin, you can already see here, diameter given to us, thickness given to us. So thickness will give us a height here. Alright, must be melted to form a cuboid of dimension this much. Okay, there's a how many coins must be melted to form this dimensions, everything given to us. So let's write down. So diameter of the coin, or in other words, it's a cylinder, right? So 1.75. and now if we know the diameter we can find the radius, right? So radius will be divided by 2. So 1.75 divided by 2, and when you divide we're going to get 0.875 centimeter. Okay, so now let's try to remove the decimal point, so it will be divided by 1000, right? Height of the cylinder they've given us 2 millimeter, but you can see that everything is in centimeter, right? So we'll convert it. So 10 millimeter max 1 centimeter. Remember, we're going from smaller to bigger, so it will be divided. Okay, so 2 by 10 centimeter. They've given us the dimension of the cuboid that we're going to form, so I've written it already here. So can I say that we'll first try to find the volume of the cuboid, okay, and also we'll try to find the volume of one coin, and then we'll divide these two in order to know how many coins will be needed to form this cuboid. So volume of the cuboid, pretty simple. They need to break into height, so just multiply, right? 5.5 into 10 into 3.5, we're going to get what volume of the cuboid is 192.5 centimeter cube. Now let's also try to find the volume of one coin. So like I said, it's a cylinder, right? So pi r square h. So pi is 22 by 7. Radius we got it to be 875 by 1000, right? 2 times. So you can see here 2 times, right? And the height 2 by 10. Alright, once we are done with that, we can divide 7 on the 7, then 7 on the 7, right? So it will be 125 of written for us here. Okay, 7 into 125 will give us 875. Alright, now once we are done with it, let's start multiplying. This 4, when you multiply, we're going to get 4812500, right? And once we are done with that, divide these two, and then you can see how many zeros are there. 1 2 3 4 5 6, right? So we'll divide it now, then it will go 1 2 3 4 5 6. That means the point will be here. Okay, so now we know the volume of one coin is how much? 0.48125 centimeter cube. Now we know the volume of the cuboid. We also know the volume of one silver coin. We just have to divide in order to know how many silver coins will be needed to form this cuboid. Okay, so volume of the cuboid divided by volume of one silver coin. So volume of the cuboid we got this much, and then volume of the one silver coin we already got it how much? 0.48125, right? So you can see that they both have decimal point, right? Here only one decimal point is there, so in order to remove it we'll just divide by 10. But here when you look, how many do I need? 1 2 3 4 and 5. Okay, division. Now once we have removed the decimal point, we'll turn this division into multiplication, which means the lower these two will change their position, right? So you can already see here. Once we're done with that, let's multiply these two. When you multiply, okay, let's divide this 0 and 0, and then when you multiply this, we're going to get this much. Alright, divided by 418124. So I've already done for us here. When you multiply by 4 times, we'll get 19250. Okay, then we'll be left with this 20, which means 400. So how many coins do we need to form this cuboid? We need exactly 400 coins, okay, to form this cuboid.